Okay. Hello everybody. This is Dr. Hassan again in electric and electronic circuit analysis. Still in module 2, single and three-phase circuit analysis. Today we will analyze three-phase electrical circuits. So it's like the second part of three-phase circuits, where we are going to discuss the Y delta connection, delta connection, delta Y connection, and power in balance system. Now, last part we discussed the three-phase when we start with star. Okay, when the load is star or Y and the source is Y also. Today, let's start with the first configuration, which is Y delta. When the supply is Y, so we have VAN, as you can see, VCN, VBN. Okay, balance system, a neutral here. Let's assume we have only 3 wires, there is no neutral wire, and the load is delta, as you can see here. This is point A, point B, and point C, okay, connected. So we have balanced load, and you see I'm using here capital letter for the load, small letter for the source, as we discussed before. Now if we come to the representation of voltages and currents, we will see that the load current IAB is VAB over Z delta, and the same thing for other two currents, which is IBC, ICA. Also the load voltage divided by the impedance, Ohm's law. And from the other side, you remember we mentioned that when we work with line to line voltage, then VAB, which is line to line voltage between line A and line B, it is equal to square root 3 phase voltage, or line to neutral voltage, VY that we call it here, with angle 30. We derived this last and proved it last session, and here just we remind you, because we need it here. We need it. Why? Because if this is for line voltages, for the source voltages VAB, we know that it's square root V phase with angle 30, and it is the same voltage across the load, which is VAB. You see capital letter here? Okay. Now I don't need to repeat the same discussion here. Just subtract from 30 120, it will be minus 290, and another 120, it will be minus 210. Okay. And if we want to find the line current, okay, IA, IB, IC, which is the current coming from the source to the load, then it is the same way. We subtract IAB minus ICA, we can find that it is also square root 3 IAB with angle minus 30. The other two currents is minus 120 minus 120, so it gives you these values. Okay, so it seems to be we are repeating the same discussion but for different configuration. Okay, now if we come to find for balance system, we can treat each single phase. We find the analysis for one single phase, which is the same for other two phases, because balance system. Okay, so you know that I delta equal VL over Z delta. We discussed this. Then IAB will be the delta current, okay, 30 minus theta. Theta is the phase shift of the delta. Okay, if we want to find the current between point A of the source and point A of the load, which is the difference between two currents on the same point, which is A, between IAB, which is out, minus ICA, which is in, then we substitute for the two currents here and use trigonometrics. What we got IAB, which is line to line, multiplied by square root 3 minus 30. Something close to this when we talk about VAB and VA, but the difference is the opposite. VAB equal to square root 3 VAN with angle 30. Okay, in a general conclusion, I load, okay, is square root 3 I phase. So I load always greater than I phase, or equal in some cases. Look, when we talk about delta connection, it is different from talking about line connection. In delta connection, okay, in star connection, V line to line equals square root of 3 V phase, but the current I phase and I line are the same. But the opposite happen in delta connection. I line to line equals square root of 3 I phase, but the voltage is the same. V phase equals V line to line. Now, also I would like to remind you with the conversion from delta to star for the load, Z delta is a 3 Z star, or Z star is 3 Z delta over 3. Okay? And here you see I'm representing one phase. This is impedance for one phase, VAN for one phase, and I can work with one phase here. Now for delta, the same principles apply now, not only on load and on supply. You can see here, on load and supply I have the same voltages, okay? And we know that the current IA equal to the current square root of 3 IAB with minus 30. We drive it before because we discussed this in delta. And IAB equal VAB over Z delta. We discussed this also in delta. I don't need to repeat the same discussion for IB and IC because it's the same, only minus 120 phase shift difference to be added. Okay? Now this is last one, which is delta star. Now if my supply is delta and the load star, the same principle for delta will be used and for star will be used. Now have a look for the delta on the load, on the supply. VAN for the supply equal VP V phase over square root 3 with minus 30. It's like we reverse the volt. You remember we mentioned that VAB at that time equal, okay, square root 3, okay, let me use them just a minute.